Afternoon. My name is Michelle Ashton. I'm Director of Communications at the Fish and Wildlife Foundation of Florida. And on behalf of our entire board and staff, I want to thank you so much for taking time out of your busy day to join us for a conversation about Rainbow Springs. A couple quick housekeeping items before we get started. Please double check to make sure that your mic is muted and remains muted throughout the duration of our time together today. The exception is during the question and answer portion at the end. There'll be two ways to participate. The first is you can use the raise your hand feature. I'll ask you to unmute and you can talk directly with our presenters. The second is you can drop your question in the chat and I can ask it for you. That option is very handy. If you have a question pop up during the presentation, you want to make sure you don't forget it, which has been happening to me all the time. So I always like having an option to write down my questions. I'm very excited to be able to introduce our presenters today. I'm joined by Bill Hawthorne. He is the aquatic ecologist at the Howard T. Odom Florida Springs Institute, and Dr. Bob Knight, who is the Institute's director. Bob, I'm going to send it over to you.
Thank you, Michelle. Well, we're really happy to be here today. This is a report on the Springs Protection License, a TAG grant 2217. And Bill and I will be making the presentation. So if Bill can go ahead and put up the presentation, we can get started. Thank you, Bill. And Bill, I will ask you to flip slides. This was an ecological health study of Rainbow Springs. We've conducted previous health studies of Rainbow in 2009 and 2015. So this is an update. Things are changing in the spring, so it's important to continue to examine how they're doing. Next slide. Bill, thank you. As I said, this project was possible because of funding from the Springs Tag Grant Program. We certainly appreciate that and the support we've been getting from the Fish and Wildlife Foundation of Florida. The work was conducted primarily by Haley Hall, who was formerly on our staff, and Bill Hawthorne. They were the field leaders. I was sort of the senior consultant, but they were assisted by a number of volunteers, including a number of science interns and experts. Steve Walsh was one, fisheries expert, and others. And then we really got a lot of support from the community. Several homeowners allowed us access to their docks, which greatly facilitated the work. We didn't have to spend hours and hours running boats at the no-wake speed up and down the river, thanks to the help of those partners. We were also supported by the state park staff, aquatic reserve staff, and the people that run KP Hull, the county. We also, some of the data come from Eckerd College from their turtle survey, and alligator data from the Florida Fish and Wildlife Research Institute. So thank you everybody for your help. Next slide. I'm going to just give a brief executive summary, and then we'll do the introduction, water clarity and quantity, biology, ecosystem level monitoring, human recreation, and sort of the wrap up. And so all the pictures in these slides are from Rainbow Springs. It's a beautiful system, as I'm sure most people know. Next slide. Okay, basically the summary is a continuation of what we've seen in the past. Flows in Rainbow are down approximately up to 20% on average. Part of the reduction is a slight decline in rainfall over the years, but there's a significant amount of it's due to just increased groundwater pumping regionally. There were over 400,000 recorded visitors in 2022. The fish populations are relatively stable, down a little bit from what we've seen in the past, but and they're not high compared to other springs, but they're definitely about the same as they have been for the last decade. Turtle populations are stable. Alligator populations are seriously declining in the river, and some people may cheer for that, but it's a top predator that's very important in the system, and that may be a problem. The nitrate concentrations at Rainbow Springs are higher than about 80 to 90% of the other springs in Florida. They're really high. They're about 25 times the natural background. And there's really no excuse for that. So that's a very important consideration. And the other thing that we noticed in this study, we hadn't noticed before, was that specific conductance and the saltiness of the water has greatly increased, doubled since 1990, and that is not a healthy trend. So next slide, and Bill, you can take over from here.
Great, thank you, Bob. Yeah, so I'm an aquatic ecologist here at the Florida Springs Institute. I started here last year in the middle of this Rainbow River project. So I did a fair bit of the data collection and then a lot of the data analysis and report writing. So I'm going to go through some of the major findings from our report. There are a significant amount of more graphs and figures and information in the report itself, and I would suggest everybody take a look at that as well. Let's see here. Great, so just a little background. Rainbow River is a 5.7 mile long spring-fed river. It's one of the largest springs in Florida, and in fact, one of the largest springs in the entire world. There is a lot of development along the river, and this has a lot of different impacts on the ecosystem itself, which we will get into a little bit later. The river feeds into the Withlacoochee River, which is then hindered by the Inglis Dam before feeding out into the Gulf of Mexico. And this river maintains incredible biodiversity. Density of plants and animals is spectacular and has very high productivity. So overall, we looked at, I believe it was 48 different sites, or we analyzed data from 48 different sites along the Rainbow River. We mainly focused our data collection at 4 different sites. We conducted monthly water quality sampling at those sites, quarterly fish and snail egg surveys, and then we did kind of this various emergent insect surveys throughout the year, a large fish survey, and ecosystem metabolism measurements. We also collected data from other sources. So we collected water quality and clarity data from our Springs Watch groups, water quality data from FDEP, biological data from the Eckerd College Rainbow River Turtle Project and FWRI. FWRI was the alligator data, and then additional flow data from WSI and USGS. So some of the main results here. So starting off with water quantity and quality, we mainly looked at data in 2 different ways. We looked at changes from the head spring downriver, and then we also looked at some seasonal differences between those 4 main sites that we looked at. So starting off here is our water clarity Secchi measurements. So this is a measurement of visibility within the water measured with a Secchi disc. We measured it at 18 different sites throughout the river, and we found water was clearest towards the head spring and decreased as you go downriver. This is very normal in springs, as water coming from the spring vent itself tends to be incredibly clear, and as it kind of picks up different plant matter and things downriver and algae starts to grow in the water column, it tends to reduce that visibility. So one really cool thing, in the head spring area, we measured visibility around 73 meters or 240 feet, which is really testament to how clear that water is at the head of the river. And then we didn't see any clear seasonal patterns in Secchi. PAR, so this is our measurement of the light that plants can utilize for photosynthesis, specifically how that light is being filtered throughout the water. So generally you lose light as you go through the water column, and PAR is a measurement of the percent of light that is reaching 1 meter depth. So kind of very similar thing. It's very closely related with visual water clarity. Generally, PAR decreased as we went downriver. This also has some effects on the plants. The less light reaching the bottom of the river, plants can't photosynthesize as much. There's going to be less oxygen production and just generally less plants. So water quantity. So we measured flow with WSI, at a few different sites along the river. And one really interesting thing here is we noted that around half of the flow of the river is coming from about halfway down the river. And this is because Rainbow Springs has a very large number of vents. And one of the largest vents is actually about halfway down the river. It's Rainbow Springs number 6. And on the bottom here, you can see a graph of flow over the year. And you can see some different changes, and that's likely mostly in part due to rainfall and response to recharge levels. So looking at historical data, we plotted annual averages for as much historical data as we could find, and then based our estimates off of linear interpolations of this graph. And so historical data was around 785 cubic feet per second, and in 2022 is estimated to be around 627 cubic feet per second, which is around a 20% reduction in flow. Previous studies have shown very similar results and have estimated that around 10% is due to rainfall, and the other 10% can be attributed to groundwater pumping. So ourselves and other entities have found that you really need around 95% of the historical flow for a very healthy spring. Below that level can cause lots more algae to grow on plants. It reduces flow velocity, and it's really bad for a whole bunch of different parameters and life within these springs. Temperature. So this is pretty basic. We noted an average of 74 degrees Fahrenheit up in the head spring. You may hear that springs on average are 72 degrees year round, but they're actually based on the average year round temperature of that area. So the more south you go, generally springs are a bit warmer, and the more north you go, springs are a bit colder. We did notice some changes you can see on this bottom graph here throughout the year. This is very common. The site closest to the head spring was the least variable. And as you went more south in the river, they were a lot more variable. And that's because just, as the water temperature is exposed to the air temperature, it changes. So generally in the summer downriver, it's warmer than the head spring, and in the winter, it's colder than in the head spring. Acidity, pH. So we didn't notice any significant differences from the head spring downriver. On the bottom here, you can see it looks like it generally got a little more basic throughout the year, a little less acidic. And this could be due to rain and flows in the river. Dissolved oxygen. So generally dissolved oxygen increases as you go downriver, and that's because spring vents generally produce very low oxygen concentration, and then as you go down the river, there's a lot more plants photosynthesizing, producing oxygen. We did not see a significant change from upriver to downriver here, and that is likely due to the large number of vents that are in Rainbow River. You'll see in a minute here, we went around and we sampled different vents, and since a lot of those vents are, halfway down the river, it might be affecting those changes that we would normally see. But also, as you can see here, though, the levels of DO are very, very high relative to other springs. Most springs are around 3-4 milligrams per liter. This spring, even up near the head spring, is around 6-7 parts or milligrams per liter. And this very high level of dissolved oxygen coming out of the springs, we believe, is one of the reasons why this spring has been so robust in the face of some of these challenges. So specific conductance is a measurement of dissolved ions in the water. And we noticed a significant change from from upstream to downstream. And this is likely just more things getting dissolved in the water column. It may also be in part due to some of these vents that we see in the middle of the spring. Looking at the historical data, this is yearly averages for as much historical data as we could find back to 1992. Specific conductance has increased a lot in that time. It's nearly doubled. This may be due to a few different things. So one, groundwater pumping can reduce the height of the aquifer. We're pumping off the top layer, and that causes water deeper in the aquifer to come up. Generally, deeper water tends to be a little saltier and higher in specific conductance. Also, this data comes from a variety of different sources, and we try to standardize it for the location, but it is possible that the methods of data collection have changed. And then it could also be due to nitrate levels. So as you'll see here in a minute, nitrate levels are very high, and that is shown with, or that's very related to specific conductance. So nitrates and nitrogen, we did not find a significant relationship with river distance. In the past, studies have shown that nitrate has decreased with river distance at Rainbow River. And their ideas there were that plants were utilizing the nitrogen. We did not see that in our results here. And we think this might be due to the spring vents. Again, as you'll see in a minute, the vents vary in nitrate. And then we didn't notice many seasonal changes, and that's kind of to be expected too. It can change with rainfall, picking up more nitrate, bringing more nitrate into the aquifer. So historically, nitrate has increased a lot, and it is very high. So the historic level at Rainbow Springs is likely around 0.05 milligrams per liter. And in 2022, in the Head Spring area, it averaged 2.39 milligrams per liter. That is 48 times above the historic level. That is very, very concerning. FDEP has also delineated a 0.35 milligrams per liter springs impairment level, where springs are likely to become more impaired around 0.35 milligrams per liter. These measurements here are 7 times above that level. So again, very, very concerning. In 2018, a BMAP was introduced, a Basin Management Action Plan, to reduce nitrate loads. And their goal was to see their goal was to eventually lower it to below that 0.35 milligrams per liter. And their 5-year goal was to get 30% of that reduction in the first 5 years. And if they were to achieve that linearly, we would expect to have seen a level of 1.6 milligrams per liter in 2022. But that was not the case. You know, it was 2.39 milligrams per liter. It's still very, very high. And this has a lot of different effects on the ecosystem, chiefly being, and one that's very visible to all of us, is all this algae growth. So we sampled 13 different vents along the river. And as you can see, a lot of these varied quite differently. For one, if you look at the very right column of this, you can see that nitrate levels were very different in the vents, and highest closest to the head spring, and then kind of decreased as you went downstream. A lot of different information here. And this might be some of the reasons that or caused some of the results that we saw with the river distance changes. So biology. So we did some biological sampling and surveys last year. Here's a summary of those. Vegetation. So we observed 7 different species of vegetation at Rainbow River, mainly strapleaf Sagittaria. This is, you know, the very long grass that's pretty much everywhere. Rainbow has a very large percent cover of vegetation compared to other springs, which is great. Vegetation is the basis of most of the life in the springs. It produces a lot of oxygen and provides shelter for a lot of animals living in the spring. We did notice, unfortunately, a lot of hydrilla. This was most common further down the river. This is a non-native vegetation that is continuing to grow in the spring. We did 2 different methods of fish sampling. So we did quarterly sampling at our 4 different sites to mainly look at seasonal changes. And you can see here that the density, the number of fish per hectare, was highest in the summertime, and the biomass was lower in the summertime. So this is an interesting result. This suggests, and this is also based on the data of the species that we saw, but it's just that more smaller fish are moving into the spring during the summertime, and larger fish are moving into the spring during the wintertime. We did a large survey. This was in the first about 1,200 meters of the river. A visual survey of fish, mainly looking for the biomass. And you can see on the bottom here on this table, we've actually been doing ourselves, and WSI, Wetland Solution Incorporated, have been doing these surveys since 2009 with very comparable methods. And you can see things have varied a bit, but are relatively constant in the springs. We estimated around 80.6 kilograms per hectare in 2022. This is quite low compared to other springs, but pretty constant since 2009. One reason it might be low is because fishing is allowed in the Rainbow River, and generally fishermen tend to pull out some of the larger fish like bass. Alligators. So this was based on data from the FWRI, who have been doing visual nighttime eye shine spotlight surveys since 2003. You can see the estimated number of alligators has significantly declined, and this is quite concerning. You know, a lot of people don't really like alligators, but they're a very important part of their ecosystem. And this decline is likely due to the harvest of nuisance alligators. So there's a lot of tubing, a lot of recreation on the river, and they're permitted to remove nuisance alligators. But because this decline is so significant, they really need to look into and possibly revise the permitting on the system. Turtle populations. So in general, turtle populations are actually increasing. And within that, we looked at each species, and each species is increasing except for eastern musk turtles. This is likely because loggerhead musk turtles are actually introduced to the system, and they are likely competing with the native eastern musk turtles. There were a couple non-native species captured throughout this entire sampling time, which is over 30 years. This is data from the Eckerd College Rainbow River Turtle Survey. But the only non-native turtle that is likely established is Trachmy scripta, which is the red ear slider. They're one of the most common animals in the pet trade, and turtles can live quite a long time, and people often end up releasing their pet turtles. And so that's likely how those turtles were introduced to this system. Birds and mammals, we observed 39 different birds during our surveys and 8 species of mammal. Largest concern here are probably the wild pigs, which, you know, pigs love mud and can affect some of the drainage and things along the riverbanks. We did apple snail surveys, apple snail egg surveys. We found an average of 18.4 eggs per meter of shoreline. This is a tremendous number. This is a huge number of eggs and shows a really healthy population of apple snails in the system. And snails have been shown to be very sensitive to oxygen changes. And so this is likely largely in part to this, you know, very robust level of oxygen that we showed earlier in the system. Emergent insects. During our surveys, we found an average of 90.7 emergent insects per meter squared per day. This is quite high relative to other springs as well, and again, likely due to the high level of dissolved oxygen. And it's quite amazing. If you've ever been out on the river around dusk, around night in the summertime, the air is like thick with bugs. It looks like fog. It's really incredible and really big testament to some of the health of this river. All right, now Bob's going to talk a little bit about ecosystem metabolism.
So we just Bill gave you a lot of specific results for different trophic levels, different levels of plants and animals. All those can be integrated or combined into a look at the overall system's productivity. This is a unique sampling method for springs, and by measuring changes in oxygen from upstream to downstream, you can get the total oxygen production for the whole system, and that is basically equal to the total power of the system in terms of production of food. The oxygen production is correlated with the carbon production, which is the food for everything. A rainbow has very high productivity. It's not the highest spring, but it's got very high productivity. It's very well, it tracks sunlight. This graph shows the daily productivity estimates for rainbow throughout the whole year period. And you see it follows the sinusoidal pattern of increasing sunlight. Low values indicate cloudy days, higher values indicate very clear days. But these are very high levels of primary productivity. We have springs that will be down less than 5 grams of oxygen per meter squared per day. Rainbow is up at averaging close to 20 grams of oxygen, 15 grams of oxygen per meter squared per day. Next. The flip side of this is as that carbon is being produced every day, it's also consumed. Springs tend to be well-balanced ecosystems where the one day's production is pretty equivalent to the next day's respiration or consumption of that carbon. That's one of the notable things that Dr. Howard Odom found at Silver Springs back in the 50s. And Rainbow is following that pattern. You see that community respiration was slightly higher than the productivity, and it's very high also. And it's sinusoidal because that's the availability of carbon through the years. There's more carbon being produced through gross primary productivity in the summer than there is in the winter in general. Next slide. We actually calculated efficiency of that by looking at the grams of carbon that are produced compared to the input of energy from sunlight. And by using constant terms in terms of kilocalories, we can measure a percent efficiency. And springs, and in fact, primary production systems, natural systems, average somewhere around 5 or 6%, like for a maximum efficiency of sunlight utilization. Rainbow is at 6.3%, which is a high level. Past measurements have been down closer to 4% at Rainbow, but this indicates that the system is functioning quite efficiently compared to other systems. Next slide. And then the net productivity was actually negative, documented in Rainbow, which is interesting because you look at it and you say, wow, it's just so productive. It's producing a lot of oxygen, a lot of biomass, but it's actually consuming more than it's producing. And the explanation for that is likely that it's heterotrophic because of the forest that lines the river on the east side is shedding leaves and shedding branches and shedding carbon that's produced outside the system and basically adding carbon to the system. A heterotrophic system is not a sick system. It's actually, most aquatic systems are heterotrophic. Rainbow's got the advantage of doing a lot of its own production so that there's a lot of food for the fish and other wildlife, but there's also actually additional food for the snails and everything that can eat the detritus from these plants, from the exogenous or the external plant community. Next slide. So we looked at human use too, and we didn't do an exhaustive survey of it, but we looked at the state's data and then had some of our own data. Next slide. Okay, so the state park measures visitor entry, and that was estimated about 320,000 in 2022. It's increasing on an annual basis based on this trend line of about 3,000 additional visitors every year. And I think everybody that lives at Rainbow or knows about it and is aware of the fact that the visitation is increasing. Next slide. We got data from KP Hull too. It's about 100,000 visitors a year. About 5% were scuba divers, and there were 342 powerboat launches. I know from my own experience that this is a great underestimate of the number of people entering a KP Hull. There's a lot of people coming in that are really not being registered, but that indicates that it's good. You know, paddlecraft are a big part of that. The tubers, a lot of tubers are putting into. Next slide. We looked at what people were doing up at the head spring, which is this station here. The activity was primarily out of the spring, but you know, and during the summertime, the warmer months, people were in the swim area, and that's the dark blue part of those lines. The lower one shows the activity, in water activities, and those primarily included bathing and swimming. Bathing is basically wading in the water where you're the water's less than waist deep, and swimming is where you're in the water fully immersed. Snorkeling and canoeing and kayaking, but this isn't a quantitative survey for the whole river. Just where we were able to get data at the head spring. Next slide. This is downstream. We're off of one of the docks, I think Gretchen Martin's dock. We're looking at what people were doing through the year. We had observers there as well. And canoeing and kayaking is the green. You can see that's biggest in the colder months. Wading and swimming and tubing are the biggest in the summer months. And this isn't news to any of you that live out there on Rainbow. Next slide. So overall activity over 400,000 people documented is probably, I wouldn't be surprised at all if there weren't more than 100,000 more than that. The main activities are canoeing, kayaking, and tubing, and scuba, powerboating are probably the most harmful activities in terms of the contact. The great thing there, Rainbow's deep enough so that tubing and kayaking don't affect the plant communities. It's powerboats and scuba that affect the plant community. Next slide. So in summary, next slide. The two biggest issues at Rainbow are the fact that it's losing its flow and that its nitrogen is still high. We suggest for all the springs a recovery to about 95% of their historic flows, and the Water Management District set a minimum flow level that only allows a 5% flow reduction, and yet the actual flow reductions are anywhere from 10 to 20%. We're not moving in the right direction. There are additional permits being issued that are making this worse. What we need to do is be cutting back on existing groundwater use permits regionally. Next slide. The nitrogen pollution is out of control in Rainbow. Like I said, this is much higher than most of the springs, and it's much higher than is healthy. And we get these incredible blooms of Spirogyra algae, this bright green algae in the upper part of Rainbow. In the lower part of Rainbow, it's sort of permanently colonized by filamentous algae to a fairly large extent. A lot of this algae doesn't really impact the native vegetation, but it is not usable for fish and wildlife. The algae are not very palatable, and as Bill showed, we're going the wrong direction. Nitrate levels are still rising in Rainbow, in spite of the fact that the state is, called this an outstanding Florida spring and prepared a DMAP that says we gotta lower the nitrate levels. We're not going the right direction there, and we won't go that direction until the total amount of fertilizer and septic tanks are reduced in the spring shed. I can tell you that from experience. Next slide. We need a carrying capacity for humans. We need that in all the springs. Especially shallow springs are just destroyed by wading and people loving them to death. Rainbow luckily isn't being destroyed from wading, but the number of scuba divers coming in and their activities on the bottom of the river, and of course the power boating those are just potentially harmful. And what we recommended in the past in the restoration plan that we did for Rainbow is that we actually put a limit on horsepower on boats so that you get rid of the ones with the deepest shafts and that are doing the most damage to the vegetation. And also there's a safety issue. You got 400,000 people going down this river with boat motors that could easily kill people and maim people. Next slide. Hydrilla is in the river. It's been in the river for a very long time. It's been treated periodically by the state. What I see is that hydrilla has taken the biggest step down in the lower part of the river, which is the most impacted part of the river in terms of overall use, and the fact that it's lower clarity down there. The hydrilla has moved up the river, but it's not out competing any of the native species. And so I don't think it's a problem in most of the river, but in those areas where it's pretty much a monoculture, it certainly could be managed better. And that's something for responsible parties to do, not just wholesale destruction of it, because it is habitat. That hydrilla is producing food for the fish and wildlife in the Rainbow River. It's also helping keep the water clearer than it would be otherwise. Next slide. And sort of a big problem is the Inglis Dam. I mean, this dam blocks, it's been there for over 100 years, but it blocks the movement of fish and wildlife between Rainbow Springs and the Gulf of Mexico. We have good evidence from silver that this is a very big effect on fish populations. And the fact that the fish populations at Rainbow are a fraction of what they are at silver indicates to me that we're not having the advantage of these anadromous and contadromous fish. And then also the larger animals like manatees that could be using the Rainbow River. So a solution for the dam issue, once again, would be useful here if that's possible. Next slide. And that's our conclusion. Thank you, Bill, for the details, and I hope the summary was helpful. And we're glad to take questions now, Michelle.
Great, thank you so much, both. And we've had a number of questions come in, so we'll just jump into it. And remember, if you'd like to add other questions to chat or ask a question directly, don't hesitate to drop those or raise your hand. So we're going to get started. Julie had a great question. What kind of, she's asking more if you could tell her about what kind of plant hydrilla is.
Kind of plant?
Yeah, you could just maybe talk a little bit about.
Yeah, hydrilla is an invasive exotic in the way it's classified by the state. It's totally filled the lake downstream. So it's really in the system, in the whole Withlacoochee River system, and it's moved into Rainbow because it's so widespread throughout Florida now. There's no stopping hydrilla permanently. It has various forms of reproduction, and so it can take advantage of all sorts of circumstances. But it has to compete with native plants when the native plants are healthy. And what we haven't seen is a dominance of hydrilla in the majority of the river. It's only dominant in a relatively small part of the river, which is really good news. It indicates to me that as long as we can keep the upper 3/4 of the river healthy, we're not going to have a replacement of hydrilla in these other species. Bill, feel free to jump in and add anything if there's anything I leave out.
Great, thanks, Bob. We're going to get to the next one. Beth asked, wading and tubers walking rather than just floating is impacting some of the shallower areas of Rainbow Springs, especially around tuber takeout. Can we talk about how to correct or improve that? Is that something, Bill, you looked at?
Yeah, this is certainly something we noticed as well, especially with the scuba divers. There's some areas where people tend to, take breaks in the shallow waters, and where they stand, it's really just kind of turned into these barren sand wastelands. So a couple ways we could improve it is to have designated areas for this, and possibly, implement, small docks or things for people to take breaks on. Also having signs that, bring awareness to this, and education, maybe pamphlets at the launches about, not standing on vegetation, not trampling over stuff. And then kind of enforcement too, if we could have people on the river talking to people about, the damage that this causes, and educating people about it, we could hopefully kind of solve these dead areas.
Thank you, Bill. That's super helpful. Elena's asking, what is the red colored water plant she sees them mostly near the spring head?
That's what we call redweed or Ledwigia. It's a plant that's common in springs, but is very well represented here. The head spring area of Rainbow is incredible diversity of plants. You almost don't see this in any other spring. So, but red Ledwigia is one of the plants that's up there.
Great, thank you, Bob. Elena's also asking what causes increases in saltiness.
So a couple different things can cause increase in saltiness. Generally, water deeper in the aquifer is saltier. And so if you have water coming from deeper, it's going to increase the saltiness. And so as we are pumping off this, the top layer of the aquifer, water is coming up from deeper, and we've seen some springs become saltier. Also, saltwater intrusion from the ocean. So there's been sea level rise, and springs a lot closer to the ocean are more heavily affected by this.
Thanks, Bill. A question about nitrates, wondering if it's due to nearby farming, lawn fertilizer. Can you talk a little bit about how nitrates are introduced into springs?
So we've completely mapped out the nitrogen loading in the spring shed and in the area around the spring shed. And the predominant source of nitrate in the springs is agriculture. And it's a combination of row crop fertilizers and animal waste. Those are the two primary contributions. Septic tanks also are a big deal in the Denellen area, the area north of Rainbow Springs. But they're not the primary source of nitrogen. But all those things together add up to a very high nitrogen loading. And we think this groundwater is actually, one reason it has such high oxygen is that it's quite shallow in terms of groundwater, the water that's coming out of Rainbow. And that means that it hasn't been stripped of its oxygen by being really old groundwater. And that upper water, the water near the top of the aquifer, tends to have the highest nitrate concentration. And that may be a reason why this one is so much higher than others. It's getting this younger water that's been more recently exposed to the atmosphere and to nitrogen fertilizer.
Thank you, Bob. And a follow-up to that, Troy's asking, are there currently any fertilizer and/or septic restrictions in place for property along the river?
Yeah, the majority of the nitrogen is not coming from the local lawn fertilization, but that certainly contributes to it. And I don't know personally what the nitrogen restrictions are in Marion County. I'm pretty sure there are some in terms of fertilizer restrictions. A number of counties have eliminated any kind of fertilization during the wet months because the fertilizer tends to get washed into the groundwater quickly. But somebody else will have to answer that question. But there's still septic systems along the river. They should all be connected to a central sewer system, in our opinion, that has advanced wastewater treatment. That is the technology that's proven everywhere else in Florida. And it's something that should be done. There should be no more septic tanks allowed at all in the spring shed, except on large properties. And there is a restriction in the 2016 Springs and Aquifer Protection Act that limits the number of septic tanks, but it's really not being enforced yet. So there are definitely things that can be done to keep things from getting worse. Just that we have a long ways to go to get things just better, to stop the bleeding, as I call it, of the system.
Thank you, Bob. Amy is asking, what data are you using to base the conclusion that boats have been harmful?
Yeah, that's a good question. So we didn't collect any data for this project specifically. We didn't collect any data on the harm of motorboats, but there's lots of data, lots of support that show the damage and harm that motorboats cause to an ecosystem. Just generally, while out on the river, we'd see motorboats go by and chop up all the vegetation. There are certain areas where it's more shallow, where you can see the lines where motorboats have gone down and just, basically given a haircut to the vegetation there. It also kicks up a lot of sand and mud, which can reduce the productivity of plants downstream. And the areas where boaters tend to stop and pull up their boats have just turned to white sand wastelands because of the boats running over vegetation, but then also the people getting out of the boats and walking over the vegetation.
Thank you, Bill. Kathy's saying that she's noticed a significant reduction in the heron population, and she's wondering if you guys have any thoughts on what could be causing that.
I don't think we have any data that showed that ourselves, but I know there's been a lot of bird observations on the river. We weren't aware of that change. So something that people need to look at more.
Great, thanks, Bob. Bruce is asking if there's any riverbank walls or other unnatural structures along the land-water interface that's causing a problem.
All the houses on the river, almost all of them have hardened shorelines, and if they're not hardened, then they may be actually pulling plants to a certain extent. That's the way you live on a river, and that's the way people have lived on the Rainbow River forever. It just any new hard structures like that add to the problems. But the river is what it is, and you're not going to get away from that. There are a lot of docks, and docks shade out the bottom so that you don't have plant communities in general below the docks, although the big bass love to sit below the docks in the shade. But there's just, I think, adding to what Bill said about the wading and everything, there just needs to be a increased awareness by the people that live on the river, that operate the boats. And I know the vast majority of them are very careful not to let their motors cut through the vegetation. That is just a no-no that everybody is aware of. But it just needs to be, everybody needs to be looking out for everybody else. And this needs to be just a public awareness and almost a shaming of anybody that is doing things that are hurting the river, because it's everybody's river. It's not one person's river or one family's river.
Well said, Bob. It looks like we're caught up on questions. So, oh no, we got one more. Elena's asking what people can do to help the Rainbow River on a daily basis.
There's a few things here, and I'm sure Bob can add some more to the ones that I'll mention, but certainly being mindful of water use. So, we talked about groundwater extraction being a big problem. And if everybody was just a little bit more mindful, we can work towards that issue. Being mindful of nitrogen pollution and nitrogen use. So, either not using fertilizers at all or using fertilizers during certain times of the year, and environmentally friendly fertilizers. And then voting. A lot of these problems are going to be changed with legislation. And so keeping that in mind when you vote.
Yeah, and so the people along the river, are irrigating as well, and some may be irrigating out of the river. I don't know. I haven't seen a lot of that, but most are probably pumping groundwater to irrigate their lawns, and we need to change that ethic completely. About a fourth of the groundwater extractions in the Florida aquifer are due to lawn watering and outside vegetation. About a fourth, and so we could make a 25% improvement on our groundwater shortage by reducing all that external watering. And the way you do that is by depending on rainfall. And so you'd see more and more people with rain barrels. I think in general, we need to have an ethic where we don't allow groundwater to be used for that purpose. And everybody basically puts in a cistern at their house to use rainwater. We have so much rainfall that we can easily, a moderate sized cistern or storage tank can provide all our water needs for things that are not potable. So that's just something I would love to see more of that along Rainbow and less irrigation systems.
Those are both both of you had really great suggestions. I just wanted to add one more, do a plug for the Springs Plate. This study was partially funded with proceeds from the Springs Plate. So if you are, if your registration is up, if you're considering how you can support Florida Springs, our Protect Florida Springs Plate, it's the one with the scuba diver on it. It's a great option. It helps us fund projects like this, many others. We do research about manatees and snook use of springs. And I think Bob can speak a lot more about the number of projects we've funded at the Institute through the Springs Plate. So just wanted to put a plug out there in case you're wanting another option of how you can protect Florida Springs. Our specialty license plate is one of the things that can fund studies like these. Great, so we've gotten some more questions coming in.
I also, though, just want to point towards Steve Walsh's comment here. Native plants, you know, a lot of the plants that people plant in their yards are not native and require a lot of extra water. If you plant native plants, these are plants that have evolved here and are used to, you know, the hot temperatures and sun and won't need as much water.
Yep. And that's another one of the diagrams we've got is Springs Friendly Yards. So the Florida Springs Institute has a program to actually honor and people that are, it's not xeriscaping or xeriscaping, it's just escaping with plants that don't need to be watered, don't need to be fertilized.
Thanks, guys. Alessandra's noting that in Northern Vermont, they have a program with people checking each boat coming and going out of lakes to educate and protect them about spreading invasive plants. Is there such a program, or could this help the springs? And I know, Bob, you guys have done a number of education outreach programs, so maybe you'd like to speak to those.
Yeah, I think Fish and Wildlife Conservation Foundation in Florida, not Foundation, FWC, they have signs everywhere about, you know, checking your prop and making sure that you don't spread invasive exotic species. And so it's pretty well known, boaters know about it, that you need to check your prop when you move from one water body to another. So I think that, but I wouldn't say that we actually have a volunteer at every boat ramp checking. We don't have that, and they probably do in Vermont, and good for them, but we don't have that. The invasives are pretty much already here, and Florida is overrun with invasives. So I'm not sure that that'll stop them once they're in, but it certainly can prevent some things. The next question there was about, is there an organized citizens group? There certainly is. Rainbow River Conservation has been in place for, 20 or 30 years. Very active group of people that are concerned about the Rainbow River. So anybody doesn't know about them, look up Rainbow River Conservation.
Great, thanks, Bob. Lane is asking, how much does Springs Plate generate each year? Lane, the funding varies depending on how many plates sold. We just had the Springs Plate Committee just met, and I'd have to go back and double check my notes, but historically we were able to fund around 10 or a dozen projects into the hundreds of thousands worth of dollars. If you're interested in any of those projects, they're all listed on our website, wildlifeflorida.org, and you can go into our grant section and see a list of all the projects we've funded and the amounts. So if you're curious about that, that's there. And if you want more information, I'd be happy to email you. My email is on our website. And yeah, shoot me a question. And that's for any of these. If folks have questions about the plates, or you have questions about today that we didn't address, feel free to shoot them to me. And I can share them with Bob and Bill, or, dig up a question or an answer on our end. So it looks like we've caught up on all the questions, and we're coming up to about 5 minutes. So I wanted to give Bob, you and Bill a chance, if you just had any final remarks or anything that's come up that you wanted to make sure we address.
Well, there's a lot of interest in the Rainbow River about a project that's being proposed to possibly dredge part of the lower river and replant Sagittaria in there. And we're very aware of that, but what we're waiting to see is a detailed scope and effort to actually accomplish that work. It's actually moving through funding, I believe, at the state level. but there's not been a good study plan that's been vetted that I'm aware of. And the Florida Springs Institute has been working on rainbow for a long time. We'd be very interested in helping to vet any, scientifically vet any efforts to make major changes in the Rainbow River. What we don't want to see is things made worse. We want to see things made better. And I don't think you can just take that for granted because somebody's going to spend some money. So I think that's an important issue that some people on the call are concerned about.
Bill, anything you want to make sure you add before we wrap up?
Yeah, I think, some of these problems seem very abstract and large, but change really comes from the individual level. And so as long as we're all doing our part and, trying to be as sustainable as we can, I really think we can see these springs jump back and get healthier. There's hope.
Well, I think that's a wonderful note for us to wrap up on. We got a question about how folks are going to be able to get the recording. So you'll notice we did record today's presentation. That will be available the same way the link to today's conversation was. So we'll be sharing it on our social media. We'll share it on eBlast. It'll also live on our YouTube channel. And then we'll be sharing it with our friends over at the Springs Institute for them to share as they see fit too. So if you have any questions about that, again, feel free to reach out to me. I'm just incredibly grateful for Bill, Bob, your work on this project and your time today, and taking time out of your busy days and research and all the important, impactful work you're doing over the Institute to take time and speak with us, and to everybody on this call who was curious, asked great questions. I'm just really grateful for everybody's interest. And again, if you have any follow-up questions, concerns, anything, don't hesitate to reach out to me. Again, my name is Michelle. My email is mashton@wildlifeflorida.org. You can find out a lot of information about our Springs Plate on our website, links to our social, all the great things. So thank you again, Bob, Bill. Look forward to talking to you again soon. And thanks to everybody who joined us, and hope you have a great rest of your day.
Thank you.
Thank you, Michelle.
Thanks.